Hey all, welcome back. Today I'm back with one more interesting topic which is race around condition. Okay, so many of you have commented me in LinkedIn all to explain about race around condition in blocking statements. Okay, so that is why I have given one particular video for that tracing condition in my channel, right? So before getting into the video, if you are new to my channel, consider subscribing my channel and hit on the notification bell. Also follow me on LinkedIn, Instagram and Quora, where I'll be uploading various important interview questions on Verilog system, Verilog and all. Okay, so let's not waste any more time. Let's dive into the topic. So what is race around condition in blocking statements? Okay, so race around condition is nothing but, for example, if we are performing, okay, like different operations. For example, if we are taking a variable a and we are performing like read and write operations at the same time on that particular variable, then what happens? Then occurs the race around condition. So what is this race around condition? Race around condition is nothing but the simulator gets confused, like whether it has to read the operation, whether it has to perform the read operation or write operation, because you are performing both read and write at the same time. Okay, so now the simulator gets confused. So either then what happens? It will eject one of the operation and it will perform another operation. Okay, so this is called race around condition. Now, let us explain this with an example. Let me explain this with an example so that you will get clear idea on what is this race around condition. So, if you see here, I have taken two initial blocks. Okay, here in both initial blocks, I have taken the same variables like A and B, but with different values. Okay, in the first initial block, A is 0, B is 1, whereas in the second initial block, A is 1 and B is 1. Now, what happens? Here, if you see, you already know when you listen about the initial and always blocks, either if we are if we are writing number of initial blocks in your module, also all the initial blocks will be starting at 0 time interval, is it or not? So either always blocks, either multiple initial blocks and multiple always blocks, we are taking also all the initial blocks and all the always blocks will be starting at the 0 time. So if you see here, both the initial blocks, when you run this particular thing, what happens? Both the initial blocks will be starting at 0 interval only. Now what happens? Since both the initial blocks are running at 0 time, now the simulator gets confused, like which to operate first and which to operate next. Now what happens? With that confusion, here I have taken two initial blocks. In the first initial block, I have taken A equal to 0, B equal to 1. And the second initial block, I have taken A equal to 1, B equal to 1. Now, if you see here, at time 0, either of the initial blocks is being simulated. So, here the second initial block is being simulated. Okay. So, based on the simulator, either first block or the second initial block will be simulated. So, now what happens? The A equal to 0, B equal to 1 value is not executed, is it or not? You can't see the value there, is it or not? So this is called race around condition. Okay, so let me for example, let us take one more example here. Okay. If you see here, this is my this is my another program. Here I have written this program based on clock. Okay, now here I am initializing, I am generating the clock, and based on the clock I am running the program. Now if you see here, the same program, like at the initial begin, I have given A equal to 0, B equal to 0. Since I have taken clock, I have also resetted the clock to 0. Okay, and then $monitor in order to monitor all the values. And then at hash 50, I have used my system tag $finish in order to end my simulation at 50 time units of my clock. Now I have to generate the clock. See, always hash 10 clock equal to negation of clock. Now what happens? The clock will be started at 10 and then it will be the total time period of clock will be 20. Did you get my point? Like at for 10 it will be positive and the next 10 it will be negate. So the total clock period will be positive plus negate, which is 20. Got my point? Yes. So if you don't know the generation of clock, I have already explained it clearly while I am explaining the always block in behavioral modeling. I'll be linking that in the description box. You can go and check it out there. Okay. So Now what I'm taking, instead of initial block, since I have taken based on the clock, so I'm writing always at the rate of passage of clock. Okay, so for here, let us first see if we are using the blocking statement, how the output will be executed. Okay, so here I am taking two always blocks, either it is always block or initial block. If you are taking multiple blocks, all will be running at 0 time. Now what happens, both will be running at 0 time only. So either this will be executed first or this will be executed first. That means at the passage, both are passages only. So at the passage of clock, either this always block is executed, either this always block is responded or this always block is responded. So now let us see this by running the code. If you run the code, see what is the output at 0. Okay, a equal to 0, b equal to 0. So this, since this is the initial values, they are displayed. And now at 10 the clock is being started, is it or not? Now at 10 what are the things that are executed? A equal to 1, b equal to 1. Why a equal to 1, b equal to 1? If you see here, see, now this passage of clock is simulated. The simulator has chosen this passage of clock first. So now the A value is 1. So as soon as A value is 1, it will be executed here. It will be assigned to the A value. And then the second always block is being executed and A equal to B. Okay, so since A is 1, obviously the B is 1. So that is why A value is 1, B value is 1. Okay, now let us do one thing. If you are taking the non-blocking assignments, now what happens? That means when you are using the non-blocking assignments, you are telling the simulator the way in order to choose the always blocks. Like you have to choose this and then you have to choose this, you are telling it. So now what happens? If I have run this code and now if you see the output at 0, obviously initial values are 0, 0. Now at 10, if you see, I have only updated the value of A. Is it or not? So now what is happening? Only A value is assigned to only one value is assigned to A. And here, since I didn't update any B value, now what is happening? B value is not assigned. So that is why B is carrying the before value only, which is 0 at 10. Okay, now at 30. Why at 30? Because at 20 the clock is negage. Okay, so it won't be responding. Now again at 30 the clock will be again at passage. So for passage what will be happening now? Since A equal to 1 in the before passage, so now A is carrying 1, then B is automatically, B is refreshing its value from 0 to 1. So that is why here A equal to 1 and B equal to 1. Okay, so this is how it will be avoiding, like these are the values you want, is it or not? At the first clock cycle I want A value to be 1, and then after some period of time I want my B value to be 1. I don't want it immediately. Okay, now if you want this in this particular order, you can't do it in blocking statements, because as I already told you, blocking statements, they all will be working in the active region. So what is the work that is done in active region? As soon as there is any change in the RHS value expression, it will be immediately assigned to the LHS and then it comes to the next assignment, is it or not? So that is why what is happening here, the assignment is immediately done before the execution of the next statement. So you can't see the exact what you are aiming for in case of blocking statements. But in case of non-blocking statements, since they are executed in the non-blocking statement, so in active statement, even though the execution is done, okay, for non-blocking statements actually the execution is done in active region, but the assignment is not done. Okay, so now what happens, this assignment is having some period of time, they are leaving some period. Okay, so this assignment, since it is done in non-blocking statement, you may not miss the particular statements. If you see here, when you are executing the same in blocking statements, what is happening, you are missing this particular thing, is it or not? You are missing this particular execution, and then what is happening, this in case of blocking statement, both of these cycles are mixed matched and the value is a equal to 1, b equal to 1, is it or not? That means what, you are missing certain values there. Okay, so certain assignments you are missing in case of blocking assignment. That is why when you are aiming for values, when you are aiming for assignments, that you need to have some these assignments at this particular time only, then you have to go for blocking non-blocking assignments. Okay, hope you got the idea, like how we are avoiding the race around condition in case of non-blocking assignment. Okay, got my point. So this is all for today. In the next video we will be talking about some more interesting topics. Okay, before leaving, if you are new to my channel, consider subscribing my channel, and also if you have if you are familiar with any VLSI aspirants, please share this video to all the VLSI aspirants, okay, who are also interested in VLSI domain, but they don't find any chance to like go outside and to learn and all. Okay, this is all for today.